Assalamu alaikum. So here we are with a new course, Advanced Electromagnetic Field and Waves. This course is for master students in physics. So today is our first lecture. So let's start. In our first lecture, our recommended book, as I shown you, that is our recommended book is Classical Electrodynamics by J.D. Jackson. So this is our recommended book which we follow, and today's topic is about, we will discuss basics of advanced electromagnetic and fields and waves. So first of all, we have to know what is basically a charge. You all of know that basically charge is a tendency of a particle to attract or repel somebody. Okay, so if a body is attracting or repelling some sort of things, so you can say this body must have a charge. Okay, so this is the basic definition of a charge. The tendency of attraction of repulsion of a body is called a charge. So charge is either positive or negative. Okay, because our course is electromagnetic, so first of all we will discuss about electric charges. You also know there is magnetic charges also, but first in this we will discuss about electric charges. Electric charges, either positive or negative. And the interesting thing is, you must have to know that like charges always repel each other, whereas unlike charges always attracts each other. This is the basic property of charges. Suppose there is a charge q1 and there is another charge q2 which is at rest, separated by some distance r. So this is basic. So because there are two charges and these charges are electric charges, so there must be some charge on that charges, either positive negative. So due to that charges, we know there is some attraction or repulsion. So due to that attraction or repulsion, there must be some force exert between these both two charges. So this force is basically this, and this force is known as Coulombic force. And now we are starting Coulomb's law. This force is known as Coulombic force, and this is so called as Coulomb's law, in which force is directly proportional to the product of charges and inversely proportional to the square of distance between them. Okay, product of these two charges, separation by a distance r, directly proportional to the product of charges and inversely proportional to the square of distance between them. So now you have to combine both this, so it becomes F is directly proportional to q1 q2 over r square. So now when you remove the directly proportional sign, there must be an equal to sign with a constant. So constant we are introducing is k, capital K. Okay, so now our equation is F is equals to k q1 q2 over r square. Here k must be either 1, sometimes k is taken as 1 by 4 pi epsilon naught, which is permittivity of free space, and epsilon r, which is permittivity, relative permittivity. Okay, and sometimes it is only if there is free space, so only taken as this, and if there is relative, if both case we combine E naught and ER, it becomes 1 by 4 pi only epsilon. So this is generalized. Okay, so let's take an interesting example. So because our charges are in space, so if our charges are in space, so we must take some coordinates. So let's take space coordinate, in which my q1 charge is here and my q2 charge is here. Now the distance from origin to q1 is r1 and the distance from origin to q2 is r2. And by a right hand rule, the resultant vector must be drawn as the tail coincides with the last tail and head coincides with the head. So in this graph you can see head attached with this head and tail attached with this tail. So this is your resultant vector, and resultant vector is the sum of other vectors. So we can say, here you can see that our resultant vector, which is r2, now it is equals to r1 plus this question mark, because we don't know the distance between q1 and q2, we have to find. So r2 is equals to r1 plus question mark. So if you want to find this question mark, so it becomes r2 minus r1. Okay. Interesting thing is that when you take the magnitude of some vector, it becomes distance. Quite simple. Okay. If you have a vector and you need a distance, just take magnitude of that vector. You will get the distance. Quite simple. Now, as I told you that the constant k is equals to this, so let's take, because we take the space coordinates, so we take the constant which is this in space 1 by 4 pi epsilon naught. So f becomes equals to 1 by 4 epsilon naught q1 q2 over r square, and this r square now becomes equals to this, as we find up r2 minus r1. So r square becomes r2 minus r1. The interesting thing is that why force is inversely proportional to r square? Why not only r? Let me tell you. Let's suppose you are taking point charges. What does point charges means? Point charges basically means unit charges. Basic unit charge, yani 1 point. And when upside the point, if this charge is large, so it becomes a sphere. Okay. And what's the area of sphere? You all know, 4 by 3 pi r square. Okay, because it's a sphere and its value is 4 by 3 pi r square, it decreases with r square. That's why its force is also decreases by r square, not by only r. Okay, let's continue further. Okay, you just have to put the value of r square here, which is r2 minus r1, we already find here. And the next thing is also, you know that vector is equals to the magnitude of that vector multiplied by their unit vector. So if you want to find unit vector, v cap, let's suppose only v is my unit vector. Okay, I'm just suppose, and so your unit vector must be equals to vector divided by their magnitude. So if, because here is my vector, so let's suppose this is my vector, so this is cap, unit vector becomes equals to vector divided by their magnitude. So first of all, you have to introduce a direction r, because it has some direction, so it becomes r cap. Okay, so now you have put the value of r cap. R cap basically means r2 minus r1 cap. So this is the value. So now you have to put this here. So this I put here. Denominator, both values are same, you just have to multiply and it becomes cube. All things are same, 1 by 4 pi epsilon naught q1 q2 by r2 minus r1 vectors cube divided by vectors, multiply in denominator vectors. Okay, this is the thing when you force on charge 2 by charge 1. But what if force on charge 1 due to charge 2? So only thing replaces is now r1 minus r2. What does it means? Let me show you. This is my space coordinate and this is my charge q1. Let's suppose this is my charge q2. This is unit, this is direction for q1, this is for direction q2. This is r1 and this is r2. Now if force on charge 2 due to q1, so it's this. In this case, which is resultant? Head with head, tail with head, tail with tail. So this is resultant, r2 is resultant. So how I find resultant? R2 becomes equals to, this is, I don't know, so this is question mark, so question mark plus R1. So if I find question mark becomes equals to R2 minus R1. This is force on charge 2 due to Q1. So that's why in formula R2 minus R1, R2 minus R1. But what if force on charge 1 due to charge 2? Again, this is my Q1, this is my Q2 charge, and this is distance is R2 and distance is R1. Now what if I have to find force on charge 1 due to 2? What I have to do? Now I have to draw this, because I have to find force on charge 1 due to charge 2. So now what is the resultant? You can see head with head, tail with tail. So now R1 is resultant. Now R1 is resultant, and R1 is now equals to question mark, which is this, plus R2. And if you want to find question mark, it is become equals to R1 minus R2. So that's why if you want to find force on charge 1 due to charge 2, so F21 becomes equals to, in denominator only just replaces by R1 minus R2, which we find here. Okay, so this is the basic concept if you want to, if there are two charges. But what if there are n number of charges? You just have to introduce summation sign. Okay. Okay, so this is simple. In this example I will take directions by x, just replaces r by x, so this becomes this. Okay, interesting thing is test charge is always very small. Why? What is test charge basically? Because in free space, if there is some charge, and if you want to find the field of, or you can say force of that charge, how you can find? You must have to introduce another charge. Due to that charge it experience some repulsion or attraction. So this is how you can find the occurrence of some charge. So that's why you must have to introduce a charge. That charge is so called as test charge. But test charge field is very small. Why? Because if this is not very small, if this is large, so it has some own field, so it disrupts the original charge field. That's why we will take it as small, so that its field never experience some sort of original charge field. Understood? Okay, and original field charge is prominent. Okay, simple. Now the next concept is electric field. Quite simple. Okay, so to find force on charge on unit charge. Okay, so this is so called as electric field. So by charge Q2, force experience F12. Okay, and if you want to find one, okay, one unit force, so it becomes, this Q2 goes downside, so it becomes F12 by Q2. So you just have to divide your Coulombic force by Q2 if you want to find a unit charge on Q2. Means if you want to find the field or force of unit charge, okay, means single charge. If only Q2, so you just have to divide force by Q2. Force U. Okay, this is the force, we already find it. So just you have put the value of force, which is this, and divide by Q2. Q2 cancels with Q2 and you will get with this single Q. So this is the electric field of a charge, okay, of a unit charge, means single charge. But what if there are n number of charges? Simple, you have to introduce a summation sign. Okay, and this is for discrete. Okay, means for discrete charges. What if there are continuous charges? So now the system is quite different. So in the case of continuous, there are three concepts: linear charge density, surface charge density, volume charge density. Okay, so let's suppose first of all linear charge density. So for the case of linear charge density, let's take an example. You have a linear rod, 0 to L is the length, and you will take a patch, and patch has a charge is dq, and patch has a length of dl. Okay, so now dl length has charges dq, and what has unit? Unit means simple, only this patch contains charges divided by unit length. Okay, this, and you have to introduce a constant which is lambda, and if you want to find charges, move dl to lambda side. Now dq becomes equals to lambda dl. Now to finish this derivative, you have to take an integration, and that integration must be line integral. Why line integral? Because you are taking the example of a linear thing. Okay, okay, so 0 to L is the linear integral, and this is lambda and this is dl. So this is how you can find the charge of some continuously disturbed field. Means if there are n number of charges and they are uniformly distributed, not discrete, that's why you will find it by charge density, and you will find by linear charge density. And there is another concept, surface charge density. Simple. First of all, you have to take a sphere, a surface which has continuous charges, positive. This unit area small has a charges dq and has a area of dA. Okay, simple thing, dA equals to dq, and now the constant is sigma, and you have to move this dA to the sigma side, and then you have to take integral, and now the integral is surface integral. Why? Because you are taking the surface. Now your charge become equals to 0 to A, which is the area, and sigma and simple dA. So this is today's lecture, only simple. We discussed in this lecture about Coulomb law, Coulombic force, electric field, and how charges are discretely disturbed, and if they are continuously in free space. So that's our first lecture of advanced electromagnetic field and waves. We will go through all lectures inshallah. Furthermore, we have total 33 lectures of this course. So stay tuned with us. Allah Hafiz.